Yes, and today we're going to have Ash, who's going to be speaking on serverless. Ash is the CTO for a startup called Vase.ai. They're in the customer intelligence space. I'll let Ash introduce more about the company. But coincidentally, one of the things I wanted to share was serverless was one of the topics I had spoken first off in Malaysia, and this was around 2017-ish, and it was at a community meetup which Ash had organized. So it's kind of like we've gone full circle right now, and Ash is gracing our event, which the folks over here have organized to speak on serverless. So with that, and just bring on Ash. Hey, Ash.
Hey, hi everyone. Yeah, thank you so much, Faz, for the nice introduction.
No worries.
Okay, cool. All right, is my screen sharing correctly? Can everyone
see? It is. So we'll move backstage, yeah?
Okay, sure thing. So, okay, hi everyone, and thank you so much, Faz, again for the really nice introduction. So, the topic for today will be serverless, going on in the Going Cloud Native for AWS series. So, a quick bio on me and why you should listen to me. So, I did my degree, or actually I studied in uni in 2013 and 2015 on computer science, behavioral econ, but I dropped out to start Vase.ai, for which I've been the CTO from 2015 until present. Currently, company is at 20 employees, 6 of which are engineering, and we build Every, which is askevery.com, which is the fastest way for you to understand your consumer. So if you're, some of the logos below are the kind of businesses who buy our software platform. Okay, so let's move on into what we're going to cover today. So today we're going to be covering we're going to go through 6 main steps, right? What is serverless? How does serverless work? Why is no servers important in the first place? When not to use serverless? And finally, some tales from our production deploy. So we actually deployed an app into production, a serverless app into production earlier this year in February. And I'll be sharing a little bit about how that has gone for us. So when you first go and find out like what is serverless, right? So I just typed serverless into Twitter and this came up. And this is a perfect example of what most people think about what serverless is, right? Which is, someone else is responsible for these servers going down. So if you don't follow I'm Developer on Twitter, by the way, you should. It's great developer jokes there. But if we go back to, in theory, what serverless is, very, very simply put, it's just write code. Everything else is handled by your cloud provider. So as an engineer, typically, when you are deploying an app, this is what it normally looks like. So even though the app that you write is only this part, you actually have a whole stack that you manage, right? When you start up a VM, let's say you start up an EC2 instance in AWS. So you have your VM, your virtual machine, the kernel on top of that, normally a Linux kernel, but could also be Windows if you're running a Windows workload. Then you have the OS, which is all the other bits and pieces around the kernel that handle stuff for the operating system. A bunch of libraries, and then finally, this is your app. So your app, or the code that you actually write, is only this part of, or this is what you control, right? However, you have to manage all of this stuff. So if, let's say, there's a security vulnerability in the kernel, you as the engineer who's deploying this stuff has to go and update the kernel, right? You have to manage the update for that. You have to make sure your machine doesn't go down. If the OS has an update, you need to make sure it's also up to date. There are definitely some people out there who are still running Ubuntu 12 or even 10 when we're right now at Ubuntu 20. If libraries have vulnerabilities, like OpenSSL constantly has vulnerabilities that are found because of it's the cryptographic library. So you also have to manage updating them as well. So it's, even though the only part that adds value and the only part you really are familiar with is the app, you have to handle all of that, right? So this is what serverless deployment looks like. So all of the gray stuff here, the VM, the kernel, the OS, the libraries to a certain extent, all is managed by the cloud provider. And you just take care of writing your app. So now some of you, of course, there are some instances where you want to have your own libraries, and for that there's Lambda layers, so that's why I added a star there, but that's not really within the scope of today's talk. So some of you guys might be thinking, oh, okay, isn't this just containers though, right? Especially if you watched last week's talk, right? Containers also give somewhat of a similar guarantee. The VM, the kernel of the OS can change, and you don't necessarily need to care about them. All you need to care about is what is in your container. And the answer is, well, yes and no. In some cases, it can look like serverless is similar to containers, but functionally, what is the core difference is serverless is event-driven. So what this means is that if let's say you have a serverless function and it's sitting there, right? In its default state, it's dead. There's nothing actually running. What happens is when a request comes in, that is when it actually comes to life. And you are only charged for the instance, for the time that the function is actually running. So function is processing right now, and then, okay, we're done. Request goes out back to the function. And the function dies back again. So you're only charged for the time the function is actually alive. On the other hand, containers are always running. They're long running. All right, you can think of them as basically sorry, my headphones died for a moment there. So you can think of them as basically mini VMs where the kernel is shared across the containers. However, the actual app itself is still running, right? It doesn't only come up when a request comes in. So as you see here, the container is incurring CPU and also memory, and then a request comes in and the container processes it. And then once the container is done processing, it's still incurring CPU and memory. So it's still incurring cost. So this is the fundamental difference between serverless and containers. So let's go over and have a quick demo on how easy it is to actually write a serverless app on AWS. So I'm here in the AWS console. So you can go over to the Lambda. If you're following along at home, you can go over to services and just click Lambda. And I have no resources currently running. You can see some charts there for when I was testing stuff earlier. So let's create a function. Okay, so AWS has actually done a pretty good job of making things easy to start with. So you can actually start not just from scratch, but also with an actual blueprint. Some of the blueprints are actually quite interesting. There's stuff to process DynamoDB. There's also stuff related to handling S3. So you can make a Lambda run when you upload an S3 object. And there's also community contributed stuff as well. So these are the ones that are community contributed, and these are the ones that are managed by AWS. So let's create a simple function. So let's going cloud. All right, I'm going to use Node.js because it is the language that I'm familiar with, but you can actually see there's quite a lot of runtimes that are also supported, including Python and Ruby if that's your jam. Or you can even provide your own Bootstrap image based on, as long as you build an image on Amazon Linux. Okay, so we're going to go ahead with Node.js, and let's just go ahead and create this function. So what AWS is doing in the background right now is it's actually going to provision the necessary resources and also set up necessary log groups and a bunch of other stuff as well. Okay, and we should be just about done. Okay. So we're going to use, to show you how easy it is to actually get started, I'm going to use the in-console editor. This editor is courtesy of, some of you might recognize it from Cloud9 because AWS actually acquired Cloud9. So what I see is I get an exports.handler and async function that takes in an event and then some response, right? So if you're not familiar with JavaScript, don't worry too much about it. What this is saying is basically I have a handler here, and this takes in the event that comes in to the function, whatever that event may be, whether it's an S3 event or whether it's an HTTP event or whether it's there's a bunch of other things that you can actually configure that we will go into later in the trigger part. So I'm just going to update this quickly to array your cloud. Oops. Right. Your, point. Let's close the quotes there. Okay, and deploy. And it's as simple as that, really. So right now, the package, the code that's running in the serverless function at least is already up to date with the latest version. But we can't actually access it because there's no trigger that is actually connected to trigger the run of the Lambda. So let's add a trigger. So as you can see, as I mentioned just now, the event that's coming into the Lambda, you can actually tie it to a bunch of different things. There's application load balancer, you can tie it to run on a log. So whenever a new log comes in, you actually trigger the Lambda. You can also tie it to S3, where you have an object that you upload. And there's even partner event sources. So if you're building a app for a client, and that client wants things to act on when they are, let's say, CleverTap, which is a marketing software, right? So they want to say like, okay, when a user clicks this button on the site, I want the Lambda to run, or I want something to run that does something. So you can actually integrate with CleverTap here and have your Lambda run when that happens. So let's create an API. I'm going to use HTTP because that's the easiest one to get started with. And leave it open, which is not advisable, but for this demo purpose, it's not that much of an issue because I'm going to take it down later. So we create that. And now we have our API gateway connected up to the Lambda. And I get an API endpoint. So if I click this API endpoint, I actually go to the endpoint. So I get, hooray, you're cloud native. And just to show you how fast this actually updates, right? So hooray, you're cloud native. Deploy that. And let's refresh this. And it's pretty much instant. So that's how easy it is to actually get started with AWS Lambda. Okay, so let's go a little bit deeper into why you want to build an app like this way instead of running it in a container or running it on a traditional server, right? So the main reason is normally less attack surface. So if we were to go back to the structure of how an app is here, all of this is now managed by you in a traditional software deployment environment. However, in a serverless environment, those are not managed by you. They are managed by the cloud provider. So this actually, so if a vulnerability comes out in OpenSSL, for example, that's on AWS to update it as quickly as possible. So you don't need to worry too much about that. Why I put mostly here is because if you write insecure code, the blue part, the part that the code that you manage, if you write insecure code and your app gets hacked, then that's still on you. But it's only your code rather than the kernel or not updating the software in time or all these other kind of issues. The second reason, which is also quite interesting, is scale to zero. And I'll show an example of why this is really amazing later on when I talk about how our production deployment has been. So what this mainly means is that you can, when the function is not running, you actually are incurring no cost. So in a container workload environment, every time the container is, no matter what, when the container is running, you're incurring costs. But with serverless, as long as there are no requests coming in, the serverless function is dead. So there's no cost being incurred for you. It's not even shut down where, like in typical AWS sense, you're incurring costs for a thing that's shut down. It's literally no cost to you at all because there's nothing running at all. There's nothing reserved for you as well. Focus on what you do best, as the engineer or as the application developer. Your key deliverable, the thing that you know best, is the code that you write, not the kernel or some library that is written by someone else, right? So why do you want to tie the security and capability of your application to that library, to managing that library? Focus on the code that you wrote and make sure the code that you wrote is the best, and leave everything else to the cloud provider. And cost is somewhat related to scale to zero as well, which is because you're literally paying only for what you use, and the function is only running when there's someone actually using it, the costs are quite different. They're quite a bit less compared to running in typical EC2 instance or ECS, Elastic Container Service. So some of you guys might be thinking, okay, that's all well and great, right? But I'm not going to write my application in the console. That's not a great developer experience. How do I even edit npm install or pip install packages? So that's where the serverless framework comes in. Now, the serverless framework is not actually by AWS. It's by a separate company. And that is why it also supports multiple cloud providers besides AWS, which we don't need to name because you probably know them. So why I suggest using the serverless framework is because it allows you to develop your code in a typical way as on your computer, while taking care of moving that code into the cloud and actually having it run in Lambda or any other cloud provider's serverless function service without you needing to change anything much on your side. So I have here, and how it starts. So I have here a code project, but I'm going to go quickly through how to actually start a serverless project. So using the serverless framework. So I'm here in the command line. First, can I quickly check that the size of the code is large enough for people to see?
Yeah, it looks good.
Okay, thank you. All right. So, all right, let's go through actually getting a serverless app started, right? So the first thing you want to do from the website is you want to basically run npm i-g serverless to get the serverless tool onto your laptop. I've already run that, so I already have the serverless tool running on my laptop, as you can see. And you run it by installing it from Node. But if you don't have npm or Node on your computer, you can also they actually have the instructions for Mac and Windows as well on how you can install it without needing to install Node per se. All right, so service is going to tell me, okay, no project affected. Do you want to create one? So we'll create a test new project. Okay, so now we've got that created. Oops, sorry. I wrote the name of the project in whether I wanted to create it or not. So yes, and you can select what language you want to make. So I'm just going to use Node.js, and now I will type test new project. All right, so we have the new project created. So when you first start out, you will see 3 files in your new serverless project. So you have serverless.yml, a handler.js or a handler.py if you use like the Python, and a gitignore. So gitignore is Git. It just ignores the folders that you shouldn't commit. So I'm not going to go into detail on that. That's a separate topic. Let's go into this serverless YML thing. So this is the configuration file that actually configures the application. So it has a service name, it has what provider. So here's where you would put another cloud provider's name if you were deploying to another cloud rather than AWS. Also your region, as well as you can configure a bunch of other stuff, including all the services you would need. So if you were building a serverless application and you needed an S3 bucket and you needed an SNS or you needed some Kinesis stream or DynamoDB, you would configure them all as items in this YAML here. And the documentation goes into a lot of detail. I'm not going to go too deep into this because of if I were to show you all the rest of the stuff, it's going to it's basic. I might as well give a talk on introduction to AWS. So I'm going to focus specifically on the project that I created earlier, which also has a serverless.yml inside it. Now I've done a few extra things. I've removed all the comments and I've added the region, AP Southeast, as well as I've renamed the function. So in the new project, when you create it, you'll see that the name of the function is hello, and it has handler here, which is under handler hello. So this is tied directly to the JS file as well as the function inside there, hello, right? So you have a function name. This is whatever name you want to call it. And then the handler to it must be a JS file or a Py file, and then inside of the dot, and then there's a function name there, which will be tied to this function name here. So if we go into my project here, it's a common use case, which is I want to know where a requester or a person who's visiting the site, or maybe who is accessing my app, I want to know where they're coming from. What country are they coming from, right? So I use a geo IP location, IP geolocation. So I have a function, geoIP, and that handler, that connects to this handler under geoip.js here, and inside there, there's a get. And inside here, it's relatively short, but what we have is we're using the maxmine library. So for those of you who aren't familiar with JS, don't worry, I'll walk through what is actually happening here. You don't have to worry too much about like recognizing the code. So maxmine is a provider of IP resolution services, and they make they make a free version of their product, which is IP geolocation, available for download. It comes in these like .mmmdb files, which are binary files, but what they are is basically a mapping between a country and an IP range. We also have city as well as ISP, so Internet Service Provider. So we use the library to open up the .mmmdbs. I already have the .mmmdbs here already. This code will actually be available on a repo that I have the link to at the end of this talk. So you can actually go and run it yourself, but you'll need to sign up for a free account in order to download these MMDB files. And then I have an event here, which basically will get the IP from the request that's coming in. And then it will return back the city, the ASN, and the country. All right, so then based on this, I can then decide, okay, I want to show maybe the app in a specific language that is tied to the country that the particular visitor is coming from. All right, so let us switch to that project. Okay, so here's where the serverless framework really shines, because to actually deploy the app is incredibly simple. Once you've created it, you just type serverless deploy. Focusing in on here real quick before I deploy, I've tied the geoIP get to a specific event, which is a HTTP event on path/JSON with the method of get. So I could have HTTP/whatever and a method of post, for example, that has a different handler. And I could have another function here that will handle, let's say, the post. It doesn't have to be called get. I just called it get, so for me to remember easily. All right, so what happens when I hit deploy is some very interesting magic happens. So what the serverless framework will do is it will actually create a CloudFormation stack, which if you are not familiar with CloudFormation, again, it's worthy of a whole other talk by itself. But what CloudFormation is you can think of it as basically a file that describes all the services that you need for this particular application. So the reason why it uses CloudFormation is because you can actually specify in the serverless.yml here, you can specify like all the AWS services that you wanted to run with this serverless application. So that is why it uses CloudFormation. And we can actually watch it happen. So I'm going to switch over to the CloudFormation tab here and ready. And then I'm going to run serverless deploy. Okay. And what you'll see is as we start deploying, okay, it's packaging the service, and then it's excluding the dependencies. Let's refresh this. We should start seeing the CloudFormation stack appearing. No, it's still not appearing. Let's go to stacks. Oh, there we are. Okay. So this is the stack, and you see right now it's starting to create. So it's creating an S3 bucket for the code. So the first thing it does is it creates an S3 bucket for the code, because generally when you're uploading Node applications, they come with the npm modules. So you have to package your npm modules with the serverless function that you're deploying to Lambda. So it generally exceeds the size of a Lambda function in itself. So normally what the serverless framework chooses to do is it uploads it S3, and then it triggers a load from S3 into serverless, into the Lambda when it's ready. So we've created the stack in the S3 buckets. And now it starts uploading the file to S3 as well as the actual code. As you can see here, it's 37 megabytes. And then now it's creating all the other resources that are necessary. So we have API gateway, which is to access the Lambda, the log group so that we can see the logs from the run, the IIM group, which I'm again not going to go into too much detail about because that's a whole nother talk by itself, but think of it as the permissions that the Lambda runs with. Okay, we're continuing to, and then finally, once we have created all that, we create the Lambda function. The Lambda function actually creates really quickly. And then we have a API gateway deployment. So, okay. And we now have the stack is complete. So when we complete, because of we specify the HTTP endpoint, we get this nice little endpoint printout at the end, which gives us what endpoint we have, right? So now I'm going to run this in a browser. Okay. And what you'll see is this will run, and this will give me back JSON with city, Petaling Jaya, Asia, Malaysia, and also Kuala Lumpur, and also my postcode, which is actually correct. So this is a very, very, very detailed, very. The MaxMind DB is very, very accurate in this regard. What you also see is for the ASN, it detects correctly that our ISP here is time, and also for country, yeah, so this is the country level. So the city level is much more accurate, gets me down to postcode basically. So I'm going to copy this link into a bit.ly right now for anyone who is watching live. So you can just go ahead and actually test it out. Just give me a moment to create the link. So paste that, create, and I'll customize this to serverless, going cloud native. Error. Let's try just serverless cloud native. Okay, there we go. I'll also paste this over to Fuzz so that you can post it in the YouTube comments. So if you go to bit.ly/bigass serverless cloud native, you should be able to also test out the IP GeoIP resolver as well. Okay, I'll be taking that down at the end of tonight because I don't want someone to end up using it and charging me for their GeoIP resolution. But I'll leave it up for until the end of tonight. Okay, so that's done actually for deploying an actual small serverless app into AWS. So very easy. Serverless framework makes it super easy to do that. So let's move on to why you would not use serverless, right? When is it not a good idea to use serverless? So there's a couple of cases where actually it's not great to use serverless. First one is non-event driven workloads. So these are, think of things like this live stream right now, or calls, video calls, right? So these kind of workloads, they're not event driven per se. They actually depend on a circuit. So they depend on there being a constant two-way flow of information between the client and the server. So this is not the right use case for serverless, because serverless is all about event driven. When a request comes in, I start up, then I shut down back. So if you were to try to do a video call over serverless, you probably end up with really choppy video. Lots of nested function calls, also not a great situation for serverless, because you end up with functions calling functions, calling functions, calling functions, and you might actually end up with your serverless app costing a lot more than your monolith app. So if you have lots of business logic tied in lots of different functions, and these functions all call each other, you might want to also think about, okay, is that really the right way to build your app? And whether there's another way that better fits, maybe doesn't have so many nested function calls. Third one is kind of tied to the first one, WebSockets kind of applications. So AWS has launched an API gateway offering that can handle WebSockets, and it can call a Lambda on start of a WebSocket, on message in a WebSocket, and end of a WebSocket. But again, you need to think a lot harder. It's not a beginner level thing, basically, to make WebSockets work with Lambda. It's not a very straightforward, like, okay, I just tie this Lambda to a WebSocket and it works. You need to actually think about, okay, how does the app start? How does the WebSocket stream start? How does it run during messages? And each of these gets a different function. Yeah. And finally, runtime of more than 15 minutes. So in AWS currently, the limit of a Lambda function is 15 minutes. You can't run a Lambda function for more than that. It used to be 5 minutes, so they have raised it to 15 minutes. However, in the end, the goal of serverless functions is really, or Lambdas, like Lambda, serverless functions like Lambda, is not to have really long running processing stuff. The idea is for it to be event driven, right? And it's very rare that you have something that it's very rare that you have something that runs for like more than 15 minutes that would be event driven. So if you have an event driven workload that takes more than 15 minutes, maybe you want to do a batch dump of data, takes more than 15 minutes, then for now at least Lambda is not the right fit for you. However, given the fact that they have increased the workload in the past, I wouldn't be surprised if they decide to do it in the future as well. Yeah. So let's move on to how our production deploy went. So this is our build, snapshot of our build in the Lambda section of our build for July. So we deployed our server engine. So Vase is at Vase, we basically build a software, as I mentioned just now, that helps companies to ask questions to respondents. And then after that, the respondents answer and we collect and analyze the data and help companies to understand the data so that they can build better products. So a key part of this flow is making sure that our platform that collects the responses from the respondents is very fast and also can scale up and down very easily, right? So 1 month we might have a lot of projects and we might have 200,000 people that we need to collect responses from. Another month we might have very little projects and we only have like maybe 10,000 responses that we need to collect. So serverless was the ideal use case was the ideal fit for our use case. And the cost also speaks for itself. So in July, we collected about 80,000 responses, and the total cost actually for the responses was actually only $1. So this $6 you see here is actually another use case. So this is the actual cost only for collecting all the responses from the people who are in our database that answer these questions. This use case is actually for logging the email events. So because of this ties to how many emails we sent out, so this is a lot higher basically. But still, we're talking almost 6 million requests costing about $1, and processing for those 6 million requests also costing about $5. In this case, there were about 400K requests, and the processing for that also was $5. So I think the costs speak for themselves. If you have a use case where it's a CRUD app, so create, read, update, delete, right? Things like people needing to put information into a database or read information from a database. Serverless is just it's the no-brainer way to build it, if you're building it today, at least. So at Vase, when we started to move into production, we started to realize that there wasn't a platform that we could use that allowed us to do continuous integration for serverless. So the situation where I wrote serverless deploy into the command line is not great when you're trying to do software development in an enterprise context, because of correctly enough, and we want to promote between those stages, and we also want to make sure that everything is not tied to one engineer needing to write deploy on their laptop. So that's when we searched around and we found Seed, which I highly recommend. So the website is seed.run, seed.run, and they basically provide a CI platform for serverless framework. So here you can see the server engine project, which is the project that I showed just now with this $1 cost here. And it's actually got a really nice UI, and it also actually gives us a way to pipeline our deployments. It's all really great, and I highly recommend it. The serverless framework themselves also have a CI platform right now, but there are some key limitations that made us stick with C. So to wrap up the talk for today, it's been about 40 minutes already. So to wrap up the talk for today, if you're building something in 2020, I highly, highly recommend using a serverless approach. If you're building something new, that is, right? If you're already editing something that has already been built, a monolith, then it takes a lot more time to think about, okay, how do I split this up? But if you think about the progression, right, we've gone from monolith to microservices, and I feel like the next iteration of this would really be serverless, right? Functions themselves that are run by the cloud provider. And I definitely see serverless becoming the default way to build most apps moving forward, because most apps that we have are really just CRUD apps, right? So they tend to mainly be interfaces between a human and a database with some business validation logic in the middle, and these are just the perfect use cases for serverless. Video and also audio calling, those are things that don't really fit into the serverless paradigm yet. I think there might be a way to make them work with the current WebSocket stuff that AWS has, but it's quite a lot of extra effort, so it might not be worth the effort to put in as well. So that wraps up my talk for today. However, I want to take this moment to quickly talk about a separate program that we're a community partner of and that I'm really excited about. So we're a community partner for 42KL, which is a pretty exciting program that I've been following since 2015 when I was in university. So 42 is actually a Parisian, it's started by this Parisian billionaire, and he basically wanted to democratize software education. And Sunway Group has gone and brought this program to KL. The program is really interesting because it's fully free, no tuition at all, no teachers. You learn via an online learning system at their center, and no typical classes. You learn basically through project-based learning. So you build projects with your peers. They're currently in the midst of their first batch recruitment. They are looking for 3,000 applicants to join into the incoming batch, and then you'll go through a couple of filtering processes. In the end, the first full batch will be about 150 people. I don't recall when it starts. And you can see the website at the bottom there. So I highly, highly encourage you to go and apply, because of the first part of it is fully online quiz style. So it's like you just complete a bunch of logic puzzles, and even if you don't get into the final 150 batch, 150 people who are in the batch as selected, the logic puzzles definitely help you to get a sense for how to think like a coder. So highly, highly recommend it. There are no requirements. The only requirement for you to join is that you must be above 18 years old. So I'm really excited that this is in KL. I'm really happy that Sunway has brought this here. I've been following it, like I said, since 2015, 2014 when I was in university. And yeah, I highly encourage anyone who wants to, wants to approach their computer science education from a different way to check this out. Yeah. Okay. And now we go into Q&A. If there's anyone who's got any questions, please comment on the YouTube or Facebook. I'm not sure where this is going up to, but yeah.
Yeah. So this is going to YouTube. I'll just
and all the code that I wrote just now in my Visual Studio Code is available on this public GitHub link, and also the slides will be available on the Going Cloud Native site, which Omar can share with you guys. That's my Twitter handle, by the way. So yeah.
Yeah, which actually went down. So.
And we're done. Oh, sorry, my headphones died again. You there, Faz?
Yeah, I'm here.
Okay, cool. Yeah, so I'm done. So we're open for questions now.
Yeah. Just quickly just typing your.
Oh yeah, thanks. Okay, so I see a couple of questions actually already. There's one on like.
First one. I'll just
holy shit! People were asking while I was talking. Okay, So serverless architecture is not suitable for long-running processes by Alavi. Thanks, Alavi, for asking this question. Long-running here currently, like I said, is about 15 minutes. You could somehow hack it, I guess, by kind of running it for 15 minutes, and then you kind of code it so that just before 15 minutes, it calls another function with the kind of completed compute. But generally, I would say that that's like a hacky way to do it. But generally, yeah, it's not really suited right now for very long running. That being said, you can kind of think of the serverless. The way you should really think about serverless is more of a wide rather than deep. So, I mean in the computer science sense, it would be vertical. It would be horizontal rather than vertical scaling. So, I'll take this example of something I was actually looking into a couple of weeks ago because I was trying to help a friend of mine with a problem that he's facing. So, he's a game asset artist, and he needs to render 3D stuff, right? And rendering 2D stuff is extremely compute intensive, all right? Especially if you're rendering an animation. So you need to render an animation. The animation was 30 seconds long, but it was, you wanted to render it at 1024 by 1024. And it's rendering from Blender, right? So the total render time was about 7 hours to render that 30-second long clip, right? So what I was trying to look into was, the reason why it's long is because it's in series, right? The processor on the computer has to render it in series, one frame by one frame, one section by half a frame, right? Could we spin up instead like 1,000 or 2,000 serverless processes, each of which is rendering a section of the frame? So you kind of think of it as a wide rather than deep, right, approach, where you parallelize massively. So any kind of thing that you're doing, which is a long-running process, generally, if it's a batch process, you can actually think of a way to parallelize it rather than necessarily running it in series. And I think this actually fits the serverless way of thinking a lot better.
Yeah, you would also look at orchestration. You would also look at trying to break it down such a way and then having a workflow orchestration of sorts around all these functions, right?
Yeah.
Because the key thing is with Lambdas, especially, they're stateless almost. So you need to make sure that you're able to orchestrate and save the state elsewhere. So Amirul actually answered that in a bit, and he actually mentioned, okay, it's not so true for long-running processes. So next we have Ayman, who actually asked, does serverless mean that computation depends on the client?
So
I guess you
no.
kind of clarified that, yeah.
Yeah, so no, this serverless doesn't mean that the computation depends on the client. Computation is not being run on the client at all. It's still being run on the cloud provider side. Just it's rather than the difference between a serverless and a regular VM or regular container is the unit of abstraction is no longer an app that is constantly running. Rather, you separate it out into the functions within that app itself, and think of it as each function of this app is separated out into separate serverless function. So let's say you have a simple CRUD app, let's say a to-do app, right? So typically the way you would write the backend for a to-do app, you would have one endpoint for, like create, one endpoint for login, one endpoint for reset password, one endpoint for delete, right? So all of these would normally live off your one app. And the app would be a web server that's constantly running and listening for any requests coming in on these 4 endpoints. The serverless way of building this would be you create 4 serverless functions. You create the create endpoint, the delete endpoint, the login, and the reset password or logout. Logout. So there's 5. And what you do is the storage, the place that you actually store the to-do would be a separate place, like a database, which is still the same as if you were running it as a regular app. And the app would call each of these functions instead of calling endpoints on the, your front-end app would call the each of these separate functions for each of the functions need to do, rather than calling endpoints on a regular backend app. Yeah.
So Omar had a question. I think this was about the serverless framework.
Yes. The serverless framework is an abstraction on top of CloudFormation. Yes. It abstracts not only CloudFormation, but like I said, it abstracts a bunch of other cloud providers as well. So you could write, this app that I wrote here right now, so I would need to it's not as simple as just changing this into some other cloud provider. I would need to change a couple of things like these. This would need to be changed a little bit. But all the documentation is actually there for all the different cloud providers. So let's take an example of so AWS, simple HTTP endpoint, and you have Ruby here. So they even have examples that you can clone as well directly from GitHub. Yeah, as well as Swift. Yeah, so AWS Lambda now supports Swift as well. What a world we live in. Yeah. Okay, next question.
Last one is, are there any beginner books for serverless? I think the documentation is the perfect one, and the serverless framework at least.
Yes, the serverless framework documentation, I would actually say, is one of the best. I can't think of a book per se right now, but just going through this, so if you go to serverless.com/framework, and then just go to learn, they have some courses here as well. They're free. So yeah, just work your way through these. I would say that the best way to learn is obviously hands-on. So yeah, work your way through these, and that will actually, I think that will really help you to get a sense. So there's actually this full stack application development here, which looks pretty interesting as well. Oh, serverless databases. Yeah. Okay, cool. Amirul, we've got a question from Amirul. Can you hit it? What is the best serverless runtime? This is kind of like asking what is the best programming language.
Yeah, I mean, what are you looking at? What do you define as best? Is it the fastest in starting, or more library support? What exactly are you looking for?
Yeah, so I guess I can say Amirul is actually one of my engineers, so I think he's trolling me. Yeah. So I mean, I'm gonna go with the Cargo Cloud explanation, right? So at Vase, we are full stack JavaScript. So what is the best serverless runtime? Node.js, hands down. Yeah.
Okay.
Okay.
I mean, there are benchmarks available online. I mean, by third-party community folks who have shown which runtimes are faster. If you see the .NET Core, the recent changes in the .NET Core runtime, and even with Golang and all, has made it much more faster compared to how it was before. And I think there was a recent change in not Python. I think it was in something else, and they said, okay, we are now faster also. So you can always compare that. I won't throw languages around because I've worked with a couple of them myself, so I don't want to show my allegiance towards any specific ones. But yeah, I mean, you could select most of the runtimes you need in Lambda and then use it in this case. So let me just take this next one. What if someone DDoSes my serverless endpoint? Can I secure myself from DDoS if I'm using serverless?
So yes, the first step is you need to set up authorization. So as I showed just now, you can actually specify in your endpoint, you can actually specify maybe JWT authentication, or you can specify another authentication method. You can use Cognito. AWS has a built-in authentication service called Cognito, which will help you manage your users as well. But yeah, you should definitely use authentication. If you're also worried, like if you're worried in general about, okay, oh my God, like, the Lambda is going to grow to be so, there's going to be so many people using it. You can also actually set a maximum concurrent function number here. So let me just scroll down so I can show you. So under the, there we go. So you can edit this here, the concurrency, and you can say, okay, reserve concurrency, like 5, I guess. Yeah, a maximum of 5 at any one time. Yeah, so that's how you can limit kind of the maximum number of functions running at one time. But generally, the price that you are out for as well also is so little that it's not really that big of an issue. AWS also gives you 400,000 gigabyte seconds free. So if we were to go over to our build just now, I'll show you. So there's this compute free tier here, 400,000 gigabyte seconds free. And that's Faz, actually, can you chime in on this? Is that per region or is that global?
This one?
Oh, I think it is per region. I think it's
per
global
region.
because
I think it's per region. But,
so I don't.
Maybe wrong.
I think it's global. I think it's global because we used up our 400 here and we couldn't use it here.
Oh, okay.
It doesn't have it here. You notice these are two different regions, right? So yeah, so it is global. But yeah, you get 400,000 gigabyte seconds, which what's a good way to think about that? So 1 gigabyte second, the gigabyte is RAM amount, and the second is second of compute. So 1 gigabyte second is a 1 gigabyte RAM instance running for 1 second. I did not go into that in more detail, but you can actually customize the memory of the instant of the Lambda function that you're running as well. So you can go all the way up to 3. And CPU, you can't really specify CPU, but CPU is proportional to the RAM. So at the 3 gigabyte instance, your RAM is, the CPU is faster-ish in some way than the 1 to 8 megabyte. But AWS doesn't really give us any indicator of how much faster. And this is where you can also specify a timeout. So you can say, okay, so the default, the hard limit is 15 minutes. However, you can actually say, no, I don't want my function to run more than 30 seconds, no matter what.
Yep. I mean, and for most of the jobs, the kind of jobs you would actually put in Lambda, the limits are enough. There are certain soft limits you can actually increase. Like if you're running like thousands, at least 1,000 is the bare minimum limit, concurrent executions within an account. And you can actually then raise that limit depending on your justification.
Wait, hold on. As I understood, the 1,000 concurrency, this actually is a hard limit, unless you're like very big.
It can be increased to hundreds of thousands. It's possible. Okay. Yeah, cool. You just have to be nice to us. That's all.
Yeah, so go and take Faz out for Arab food, and then he will help you to release it.
Yeah, that's my weak point. Thanks. Yeah, so I've actually shared the links across. So there's one about the DDoS. On the DDoS, there's a white paper which we've given on best practices. One section of that talks about API endpoints, where you can also use WAF along with CloudFront, and then put that in front of your API gateway. WAF allows you to configure rules so that it can mitigate any DDoS.
That's for web application firewall. Yeah.
Yeah, but you can front it in front of an API gateway also. Yeah. And WAF has been adding a lot of things under the hood. There is machine learning algorithms being used for anomaly detection, but then you can configure your own rules if you're sure exactly how you want to do it. There are workshops and content available online to know how to exactly do that. But yeah, what's the next one then? Prerequisite knowledge before reading.
Yeah, there's one person who's asking about prerequisite knowledge for reading serverless documentation. Honestly, I think just jump in, read it, and then when you find things that you don't understand, then go and Google those. Yeah, that's generally the better approach to learning stuff, rather than kind of thinking, okay, what do I need to read prerequisite first? Yeah, so I'd say start with the free courses. Start with these two. Those are an hour and 2 hours respectively. So I mean that should give you enough of and these are videos. So that should give you a pretty good sense of how to get started thinking about this things from a serverless point of view. And then after that, you can go and check out the forum as well. I haven't used it myself, but I mean, serverless is something that a lot of people are pretty interested in, and generally new tech. Can I say serverless is new? Serverless is not really new. I mean, but
new. I spoke about it in 2017.
Exactly, right? So, but I mean, yeah, looking at it, it seems like it's quite active, and there's a lot of people requesting help and also asking this. So yeah, sign up for the forum and ask in the forum, right? Or also ask in, there are Malaysian engineering groups that you can ask in as well, like engineers.my, and also on Facebook. Yeah, there's a lot of places you can ask for help, basically.
Yeah, I just start reading. I think there's a lot of content available, free content, especially on YouTube, Free Code Camp, and a lot of other things there on the
I would say
AWS
start
website
doing.
also. Yeah. I mean,
Yeah,
do it while
yeah,
learning. So do a tutorial when you're actually doing it. Don't go too much into the theory first. Build something out.
yeah.
Best programming language ever, anything but Java. I'm a Java guy. Don't say that. I feel bad already. I mean, I did Java for like 11 years before switching to C# because of my previous job. So I've been there, different languages across. But yeah, I mean, different languages. That's all I can say. These are the links which I've shared already on white papers, and then also on getting started limits on Lambda if that's required. Also, I was going to actually ask if there is anything else. Right. So, I mean, I was going to ask how one would get started, especially because we have a mix of folks who are uni students and then fresh graduates, right, who are just getting into the job workforce. You've kind of answered most of the documentation part. Is there anything else you would also want to advise them in terms of how to get started? Because on AWS, you have a free tier that's already available. You can just sign up
Yep.
with your
So
card.
400 gigabyte seconds. Yeah, 400 gigabyte seconds will cover you for almost any personal use case that you have. You could host your website on serverless. Like,
Right.
yeah. I mean, you can also host it on S3. So, like, yeah, but you could host it on S3 and then have like a contact us form or something that takes in the backend takes user serverless, right? So I was actually browsing through this earlier today and I found something really interesting. Let's see if I can load it up quickly. So there's actually I don't recall if it's a AWS sanctioned one or whether it's a community one, but there's actually a form. Let's see. No. There's actually
a contact us form. Yeah, I think I remember seeing that before. Form handler, the first one? Serverless form handler?
Yes, so there's a form handler and there's also this contact us form, right? So literally, this will accept a form submission from your website. And then it will send you an email via SES. So it's fully configured with all the AWS services that you need already. You just specify the application name as well as the email. So you need to set this email up in SES first before you put it here. But to verify in SES, you just need to put the email in, click a verify link when it sends you the email, and then it's verified, right? And now you can have a contact us form that calls the API that's generated by this template, and then it will send you an email through AWS.
Yep.
Yeah.
So gone are the
tons of
days.
stuff.
Yeah. Gone are the days of running a single PHP file for contact us.
Yeah. So I mean, I would say to get started, right? Go browse through these public applications. There's a ton of stuff here that's really interesting. And if like the next time you're trying to build something simple, or you're trying to think about, okay, I need something very simple that does this particular thing, right? Yeah, go check out functions and go search if there's something here that already fulfills what you need to do, right? And that's how you get started. That's how you start building. That's how you get better. Yeah.
Cool. So I think last question with Ayman also adding on to this. So as an employer, what do you think about the various tech certs? And Ayman also wanted to add about Microsoft cert. I can't speak about Microsoft. So
Okay, so certifications, to me, they are a plus, but they're not a must-hire, if you get what I mean. So what that means is you getting a certification shows me that you're thinking about your employment in beyond just thinking about, okay, I get a good GPA or I get a good degree and then I'm set, right? So that's definitely a trait that I like in people who I'm trying to hire. What certification specifically, it really varies on a case-by-case basis. We don't run any Microsoft stuff in our cloud. So Microsoft certifications, they signal to me that you were definitely thinking out of the box in terms of education. So that's a good trait. However, having, let's say, a Microsoft professional certification versus having a high-level Microsoft certification versus a low-level one, I can't really grok in my mind how that would be different. To me, they mean the same thing in that they both signal to me that you're thinking about your education in a non-standard way. So that's already a good thing. Yeah. AWS, so I do think it's useful, especially as we move into kind of more companies in the world realizing that, you know what, a typical 4-year CS degree really doesn't cut it. Oh, by the way, on that note about 42, so their program is 1 year. So in 12 months, they basically bring you from someone who doesn't know how to code to a hireable software engineer. So yeah, that's also like a 4x increase in speed over a traditional CS degree. So yeah, definitely check them out. But yeah, so in a world where, you know, CS degrees employers are realizing that CS degrees don't really directly indicate the ability to perform as a software engineer anymore. Certs definitely have value, and they're definitely worth getting. I would say, think about it the same way you think about getting your degree, right? It's a piece of paper that's nice to have, and definitely for the people who care about it, it adds value. But don't rely on it as like, okay, because I have the cert, then I'll definitely get a job. That's not the case.
Use it as an enabler of sorts, but don't think it's the only way to actually get through.
In your interview, you can use it as a topic of conversation. You can actually bring it up and say, no, why I thought about getting this cert, etc. Right? So
Yeah. So, I mean, it totally makes sense, because you would want, as a person, as an engineer, whether you're in college or whether you're just joining the workforce or been in the workforce for quite some time, think of a certificate as a way to validate what you've already learned. So it's always preferable to do a cert when you've actually had some hands-on experience, which is why they mention it. However, it's not a like hard rule, fast rule. There are folks who haven't touched AWS a lot and then have gone and done a lot of certs also, whether it's AWS or any other cloud provider. So you, even as an employer, if you are taking someone's resume and seeing, okay, they have a cert, even if it gives you confidence, you should still check and double check whether the person knows what they're talking about. So that's basically as an employer also. And as an employee, you should know that, okay, if you're confident with whatever you have learned and your experience, use the cert as a way to validate what you've already done, right, through your work, whether it's on freelance or in an actual job. The cert syllabus, at least I can speak on AWS's behalf. The certification syllabus in AWS, the kind of questions that are asked are always revamped every 2 to 3 years. Every exam gets revamped, so you're always getting the latest. Sometimes even I also sit and write the exams, and sometimes I would use the exam as a way to know, okay, these are topics I should be focusing on right now, right?
When you say write the exams, you mean you try to answer them, not that you actually write the questions, right?
Yeah, write the exam. Sorry, answer the exam.
Right.
Don't prepare the questions.
I was like, are you the ones creating the questions? Because if that's the case, definitely bring Buzz up for Arab food, right?
No. Yeah, so it gives you an idea of what's happening in the market right now. So definitely use it as an indicator of sorts. But yeah, I mean, certs, in a way, it's good to have them, but use them wisely is what I would suggest. Cool. Yeah. So no other questions then. So yeah.
There's one more question actually from the internal chat that I want to quickly address because I think it's a good question as well, which Labib actually asked. So he's asking, like, does serverless mean that you have less control over the virtual machine? Yes, it does. So in a typical serverless sense, you saw just now when I deployed the serverless function, right? I didn't configure what libraries are supposed to be installed on the machine. I didn't configure what version of Node.js that's running, right? I selected from that list of what runtimes there is, and I have to kind of take it on good faith that AWS has all the right libraries for running a Node application installed, right? I don't mean things like the NPM libraries. NPM libraries you have to actually ship with your application. I mean like lower level libraries like OpenSSL, like the libc, the C library, etc. All these kind of lower level libraries that are part of the typical Linux install. That being said, AWS has shipped this thing called Lambda layers, which I alluded to very quickly in a previous slide, which actually allows you to package a set of extra libraries that you want to have installed. So for example, one of the things that actually is not available in a typical AWS Lambda Node Lambda install is ImageMagick, right? ImageMagick, you can install the NPM library, but it relies on a C library underneath it. And that C library by default isn't installed in the typical Lambda runtime. But there are a bunch of people who publish layers that have it installed. So you can just use one of these layers in your Lambda application And that allows you to use these libraries on top of kind of the basic install as well. Yeah. I think it's important to address that. Yeah.
Yeah, that's good. Thanks for that. I think Lambda layers as an option is useful, especially because one of the beginner mistakes, I would call it, is when folks start adding a lot of packages and libraries in as part of the Lambda code. You would instead want to leverage off of layers so that you can avoid doing that. Plus, the layers gives you a centralized way to manage all of these, so that other let's say other people in your team can also share it and use it as part of the application code.
Yeah, and Brahman, there's Java here, so if you want to use Java. If you want to use Java to write your serverless application, you can.
Yeah, Java 11 also already latest supported. Why not?
So for those of you out there who are like hardcore C programmers who are like, oh, C is not supported, right? The interesting thing about Lambda as well that was actually exposed by the fact that it supports Go, right? Is if those of you who are familiar with Go will know that typically when you run a Go application, you actually compile it into a binary and then you ship that binary. So the Golang runtime here, you're actually shipping the binary to AWS. You're not shipping like your Go code and it compiles it. So the fact that you're shipping a binary actually means you could also technically compile any typically Linux runnable binary, and it should work in Lambda runtime as well. So if you're a hardcore C programmer and you're like, I will not write anything else but C, but I want to write a serverless application with C, you can do that by selecting the Go runtime and shipping your C binary.
Yeah. And there are folks who have built some kind of transpilers in the side. For example, Rust, you can actually bring Rust in also.
Yes,
so Rust is a programming language. So you can just bring that and provide your own runtime. I mean, almost your own runtime and then run it. So yeah.
I think the only one that's missing here right now, but I guess you could also create a custom runtime, is COBOL, right?
Wow. Yeah, why not, right? I mean, that's the only thing left for us to bring all the legacy apps in once and for all.
Yeah. Okay.
Cool.
Yeah.
All right.
I don't think we have any other questions.
Yeah, cool. All right. So no other questions then. So with that, thanks a lot, Ash. I appreciate your time with us in sharing all of this. It's kind of cool to see that you actually jumped. I think one of the comments I got behind the scenes was that you actually jumped in directly into the demo and showed how you're actually building things and then talking through it. I think that really helps people to understand the thinking process when you're actually implementing something new, especially when it comes to serverless, because it requires a different thought process itself.